function. We say that the function f of t is periodic of period capital T, and we assume that capital T is bigger than 0 if f of t plus capital T equals to f of t. Only t in the domain. In particular, we'll be considering so-called square wave function. Example, square wave function looks like which looks something like it's positive 1 from 0 to 1, then it's negative 1 between 1 and 2, then it's positive 1 between 2 and 3, and so on. So it looks like a square wave. And see that. So, for example, the square wave will have period of t, capital T, which is going to be equal to 2. So we need to give one more definition. I will define, so we define and have sub capital T to be restriction of our function on one period, and it's going to be equal to 0 always. So we can try and calculate Laplace transform of one period of function. So we'll calculate Laplace transform of now we'll try to calculate Laplace transform of that one period of function f of t. If you look what we have here, and that's f multiplied by a window function between 0 and the period capital T. So we're going to get that equals f of t multiplied by unit step function minus unit step function t minus period capital T. And I'm going to break the two difference of Laplace transforms. Laplace transform function f of t times unit step function minus Laplace transform of t multiplied by unit step function t minus period. Notice that the function in the first one, Laplace f of t times unit step function of t is the same as Laplace transform of original function minus. Recall what is the formula for Laplace transform of when you multiply by unit step function. So we're going to get Laplace transform of f of t plus extra period times e to the negative s times capital T period. So we're going to get Laplace of f of t minus, because our function has period capital T, so we conclude that expression function here is the same as f of t, because capital T is a period of function, so we're going to get Laplace of f of t to a negative st. So what we have is Laplace transform of one period equals 2. Here we can factor Laplace transform of function f multiplied by 1 minus negative st, from which we're going to get Laplace transform of f of t equals to Laplace transform of one period divided by 1 minus e to the negative s. Capital T, it should be capital T. If you like, we can rewrite that as a theorem. If f has a period t and f is piecewise continuous on interval from 0 to t, then Laplace transform of function f is going to be equal to Laplace transform of the first period divided by 1 minus e to the negative s by period t. And to calculate Laplace of the first period, we do it directly. We calculate the integral from 0 to t e to the negative s times period s times little t f of t. So that's going to be how we're going to be calculating Laplace transform of periodic functions. So let's run an example. So in our example, we'll try to find Laplace transform of a square function, which was given here. So for that square function, if we look to f of one period, then one period is going to look something like, it's going to be equal to 1 between 0 and 1. And then it's going to be equal to negative 1 between 1 and 2. And after that, it's going to be equal to 0. So that's f of t. So to calculate Laplace transform of t, we're going to get, carefully look what is written there, then we can visualize that it's 1 times window between 0 and 1 minus 1 times 0 times window between 1 and 2. And we take Laplace of that expression. That the window between 0 and 1 equals to u of t minus u of t minus 1 minus, well, window between 1 and 2 is u of t minus 1 minus u of t minus 2. Then we recall what are our formulas for Laplace of unit step functions. So we're going to get Laplace of unit step function is e to the negative s times 0 divided by s, minus for unit step function t minus 1, we're going to get e to the negative s times 1 divided by s, minus for Next one, we're going to get e to the negative s times 1 divided by s. Minus minus give me plus. So e to the negative 2s divided by s. Combining like terms, we're going to get plus of f1 period equals to 1 over s minus 2 e to the negative s divided by s plus e to the negative 2s divided by s. Now, complete plus of the whole square wave function f of t, square wave function, we do Laplace of f of t equals, using the formula which we derive right here, we're going to get that equals to Laplace over first period divided by 1 minus e to the negative s multiplied by period. We're going to get, we already calculated plus 1 period, so we're going to substitute it here. So we're going to get 1 over s minus 2e to the negative s divided by s plus e to the negative 2s divided by s divided by 1 minus period equals to 2. So I'm substituting 2 for capital T, e to the negative 2s. And then I'm going to simplify that expression. I'm going to multiply top and bottom by s. So we're going to get Laplace of square unit function equals 1 minus 2 e to the negative s e to the negative 2s divided by 1 minus e to the negative 2s multiplied by s. We can simplify it further. Notice that on the bottom we have difference of squares, so 1 minus e to the negative s multiplied by 1 plus e to the negative s. Also notice that on top we have complete squares, so we have 1 minus e to the negative s squared. So we simplify that expression and get simplified version for our answer as 1 minus e to the negative s. So one copies of 1 minus e to the negative s on top cancelled with 1 on the bottom, and on the bottom we have 1 plus e to the negative s by s. That will be the Laplace transform of square wave function.